In this video, we will continue our discussion about balancing of chemical equations. In the previous video, we discussed the initial lesson, and right now we will be practicing what we have learned. We will apply the skill with we are going to deal with 5 problems in total. So the instructions state that we have to balance the following chemical equations. Let's start with number 1. First, we have to list the reactants and the products. So for the reactant side, we have nitrogen, oxygen. Product side, we still have the same, nitrogen and oxygen. So, and list the subscript quantities. So for in every element or compound that has no subscript whatsoever, it's already understood that their subscript quantity is 1. So right now we have O sub 1 and O sub 2. We add them together, we get an odd number, which is 3. And at the product side, nitrogen is 1 only, and we have 2 oxygens. Now, there's a simple rule in balancing of chemical equations that we must eradicate an odd number to balance them easier. So, suppose, in order to remove the odd quantity, let's say we place 2 at NO at the reactant side. Therefore, N will become 2. There will be 2 nitrogens, and we multiply oxygen with 2. We get, actually we don't multiply 3 and 2. We eradicate the number 3, the odd number 3, and we just basically place 2 here. And that will be the new quantity or amount of oxygen. And if we add the O sub 2 at the other side, another reactant apart from this reactant, we get 4. So in that case, we'll have to place 2 here as well, and that will be a different color to prevent some sort of confusion. And with that, we multiply this nitrogen with 2 at the product side, we get 2. They're equal now. For oxygen at the product side, 2 oxygens times 2, we get 4. And hence, our equation is balanced. And yes, we'll just leave 1 here. And yeah, this is the final answer. For the reaction type, this is just a bonus question. I just wanted to tell you that reaction type for this is synthesis. As we all know, this is the combination reaction. Provided we have A and a B, our result will be an AB. It's well said. Since, just look at the science behind this. A plus B is AB. Let's move in number 2. For the reactant side, let's list. We have sodium, we have hydrogen, we have oxygen. Just to tell you, why did I separate H2O? Shouldn't they be together when enlisting the reactant and product sides? Well, H2O, water, is not an ion. There has to be either a positive or a negative charge in order for a compound or an element to be, or maybe a compound, just a compound, to be an ion, whether it be a cation or an anion, an ion with positive or either negative charge. I think you could understand this already. Should there be any questions, please comment below. So yes, for the product side, you have sodium, oxygen, then hydrogen. For sodium, we have sub 1 because there is no subscript whatsoever. For oxygen, we have 2. We're talking about the reactant side, by the way, just so you know. Now we're going to talk about the product side. For sodium, we still have 1. We have OH. Hydrogen is 3. We combine 1 and 2, and we have 1 oxygen. In that case, we'll have to balance hydrogen because they're the only ones that aren't equal. So let's use our dark purple. We multiply 3 with 2, I suppose. So at the product side, I know that we do have an an odd number again. So we have to eradicate that so that we could balance properly. Because in my opinion, I don't think there's any way to balance it apart from eradicating the odd number. So here, at this part, let's add 2. So in that case, sodium times 2, we get 2 sodiums. For oxygen, multiply it with 2 also. For hydrogen, it has its new quantity at the product side. It's 2. Then we add this, so we get 4. Alright, so I think that's a deal breaker. Let's continue with balancing sodium at the reactant side to make them equal to each other. So there you go. Sodium is now balanced. For hydrogen, multiply this with 2. Oh yeah, by the way, I have to switch color. So we get 4. And for oxygen, we also multiply with 2. Well, technically yes. Hydrogen and oxygen are already equal, respectively. And in that case, it leaves us to consider this H sub 2 with a coefficient of 1. So this is our final answer. This chemical equation is now balanced. And for the reaction type, the chemical reaction type, it's going to be the single displacement. You might ask why. Please recall the previous video that we had about the types of chemical reactions. As you can see here, at the reactant side, H2O used to be together with oxygen, but now it's together with sodium, by which sodium used to be alone in the reactant side. So yes, it's a single displacement. For number 3, let's continue. Reactant side and list, we have magnesium, we have OH sub 2, actually just OH. We have sodium and SO sub 4. Alright, at the product side, they're just the same basically, as always. Alright. For magnesium, we have 1. At the other side, we also have 1 at the product side. For OH, we have 2. At the other side, we only have 1. You might ask why OH is combined. Why don't we just place oxygen and hydrogen as separated? Well, the provided parenthesis, may mean something. So it could be a clue that these are together. They're an ion, maybe. Maybe not, but still, they're separated for some reason. For sodium, sub 2, so subscript is 2. SO sub 4, it's just 1. Please acknowledge that they're together. This is an ion. I'm not exactly sure of its UPAC name, but please consult the list of ions. There might be a delay in the video about ions, but still, you can check on other resources. So SO sub 4 is just 1 quantity. At the other side, at the product side, it's also 1. For sodium, we also have 1. Okay, start with dark purple. For OH, we multiply this to 2 to get 2 to be equal to the reactant side. So we locate OH, it's here. For sodium, we distributive property again. So Na times 2, we get 2. So yes, I suppose they're equal now. That's everything that we had to do. The rest, place a coefficient of 1. And for the reaction type, this is a double displacement. Oops, there you go. You might ask why. Mg used to hang out with OH sub 2. I mean, open close parenthesis OH, open parenthesis OH, close parenthesis 2, sub 2. Magnesium used to hang out with that, and now magnesium, it hangs out with SO sub 4, which SO sub 4 used to hang out with sodium in the first place. So yeah, two chemicals swap each partner. For number 4, for the reactant side, we have calcium, PO sub 4, we have sodium, and NO sub 3. Right, we'll just copy paste that for the product side. They're always the same, but the subscripts may not be the same always. So for calcium, reactant side, we have 3, PO sub 4, we have 2, sodium, we have 1, NO sub 3, we have 1. NO sub 3 at the other side, we have 2, sodium, we have 3, PO sub 4, we have 1 only. Calcium, I wonder why there are answers here. Please, for the sake of the discussion, try not cheating on yourself. I apologize for that inconvenience. Please, just write the chemical equation without the coefficients. For calcium, you only have 1, since Ca is also equal to Ca sub 1. So let's equalize, let's make balance the calcium part. So with that, NO sub 3 times 2, well, you multiply 2 and 3, we get 6. And at the other side, at the reactant side, you multiply NO3 with 6. You also multiply 6 with Na. There you go. And Na at the product side is 3. So we multiply it with 2, you get 6. So with that, Na sub 3, you multiply PO sub 4 with 2, so 1 times 2 is 2. So suppose it's equal already. Calcium equal, okay. PO sub 4 equal, sodium equal, and NO sub 3 equal. So that's how you balance chemical equations for number 4. 6, 3, 2, coefficient here is 1. Reaction type, the same as number 3, double displacement. Since calcium used to hang out with PO sub 4, now it hangs out with NO sub 3. And for Na, it used to hang out with NO sub 3, now it hangs out with PO sub 4. So there's an exchange, double exchange. Number 5, let's enlist. So we have carbon, hydrogen, oxygen. These aren't ions, so we'll just separate the elements in it. They're just compounds. They don't have any charge whatsoever. So CHO at the other side too. In that case, let's enlist carbon and hydrogen. We have 6 at the reactant side. We do have 2 oxygens also. At the product side, we have 3 oxygens combine O sub 2 and O sub 1. 2 plus 1 is 3. For hydrogen, we have 2. Carbon, we have 1. Now, in order to make balance with carbon, we multiply it with 6. Let's try. The best thing that we could do right now is try and error, especially when the chemical equation looks difficult or tricky at some extent. So let's place 6 there, and O sub 2. Maybe let's try not doing that for now. Let's prioritize making this quantity even. Again, as I said earlier, odd numbers may interfere with our solution. It's going to interfere it badly. So let's assume place 2 there. In that case, this will be 4. And for oxygen, we have 2. Which, if you add O sub 2, we get 4. For oxygen at the other side, actually I'm not certain about this problem. Give me a few seconds to consider. I'll just write reaction type for later. Okay, I think I can see some answers now. I'm sorry, I should have continued the first solution a while ago because it was correct. So we place 6 there at carbon dioxide. 6 and 1, so 6 times 1 times 6 is 6. Carbon is now equal with the reactant side. So for O sub 2, we get 12. Then for for hydrogen, if you multiply this with 3, we get 6. So hydrogen is equal with each other. And with that, we place 3 here. Because hydrogen, as you can see, H sub 2, 2 times 3 is 6. So we get H sub 6, which is translated into 6 hydrogens. And distributive property, we get 3 oxygen, so 12 plus 3, we get 15. Now, with this solution, let's just change the style of this. Light purple. For oxygen at the reactant side, in order for it to be equal to 15, suppose in your mind you might want to multiply it with 15 over 2 so that you get 15. So that's how you do it. 15 over 2 here, and I suppose that the equations are balanced already. I mean, the variables in the reactant and product side. So we leave this part with just a coefficient of 1. Now you might think this problem is different compared to the other problems because this time we have a coefficient that is a fraction. Well, there is also a rule that allows us to make the coefficients whole integers so that for the sake of reducing any confusion. But still, this is already correct. If you want, you may multiply everything with 2 since the denominator is 2. So C6H6 plus 15O2 is equal to 12. CO2 plus 6H2O. So this could also be an answer. The only difference is we eradicated the denominator of the fraction because one of the coefficients is a fraction. So yes, I suppose that is everything for number 5. Just connect these. Oops. There you go. For the reaction type, if you've understood the video that I had last time about types of chemical reactions, the last chemical reaction, which is combustion reaction, you can identify this with its format, which is basically any chemical equation with a pattern of HC plus O2 is equal to CO2 plus H2O. So if you haven't known about this yet, you might want to watch it. The link, actually I won't be providing a link anymore. The video is really new. It's only been a few days ago since I made it. All about the types of chemical reactions. So yes, that's everything. You can see that we can match CH or HC, then we have O sub 2, then we have CO2, then we have H2O. It's a perfect match. So reaction type for this is a combustion reaction. I hope you've understood at least something in this video. Thank you for watching. By the way, I almost forgot to box our final answers. There you go, duplicate. That's for number 4. Number 5. Any of these answers are considered okay, acceptable. Any of these two. So yeah, thank you.